Good morning, dear student. Today I will discuss some numerical of Laplace transformation of periodic function and evaluate the sum integrals. Now I have discussed numerical. Find the Laplace transformation of periodic function ft is equal to t when 0 is less than t is less than pi and pi minus t, pi is less than t is less than 2 pi, and also draw the graph. Now solution of this numerical. Let the periodic time is 2 pi is equal to capital T. We have ft of periodic function is equal to integration 0 to infinite e to the power minus st into ft dt total upon 1 minus e to the power minus s capital T. Now apply this function ft. So Lft is equal to 1 upon 1 minus e to the power 1 minus e to the power minus s t bracket integral 0 to pi. Now break this type of integration 0 to pi e to the power minus st into t into dt plus integration pi to 2 pi e to the power minus st into pi minus t into dt. Now you can solve this. 1 upon 1 minus e to the power minus s capital T bracket integration 0 to pi e to the power minus st into t into dt plus integral pi to 2 pi e to the power minus st into pi minus t into dt. Putting capital T is equal to 2 pi. Now one upon 1 minus e to the power minus 2 pi s bracket integral of this 0 to pi e to the power minus st into t into dt plus integral pi to 2 pi e to the power minus st pi minus t into dt. Now solve this integral. 1 upon 1 minus e to the power minus 2 pi s bracket integral of this you can solve by Euler method. T into e to the power minus st upon minus s minus e to the power minus st upon s square limit 0 to pi plus solve this integral is also pi minus t e to the power minus 2t e to the power st upon minus s minus solve to this integral minus 1 e to the power minus st upon s square is also putting the limit pi to 2 pi. Now solve this integral. 1 upon 1 minus e to the power minus 2 pi s bracket putting the limit 0 to pi. First off putting the pi. Now you solve this. If put the pi e to the power minus pi s total upon minus s. Now again put the pi minus e to the power minus pi t pi s upon s square. Now again minus, if value put the 0 is equal to minus 0. Now plus put the value of 0 is equal to 1. It means 1 by s square. Now again solve plus limit pi to 2 pi. Now put first off 2 pi. You solve this. Pi minus 2 pi is equal to minus pi. Now e to the power minus 2 pi s upon minus s. Now minus is plus e to the power 2 pi s e to the power minus 2 pi s upon s square. Now put the value of pi is equal to minus, first put the value of pi minus pi is equal to 0. Now open the bracket, minus plus minus value put pi, it means e to the power minus pi t upon s square. Please you can solve this, and now you write this. I have next. Yes, this is right. Now you can solve this. 1 upon 1 minus e to the power minus 2 pi s bracket putting the value of this solve by I have common. Now similarly I will solve pi e to the power minus pi s upon minus s. Now minus e to the power minus pi s upon s square. Now plus 1 by s square. Now you can solve this plus pi e to the power minus 2 pi s upon s, now plus e to the power minus 2 pi s upon s square minus e to the power minus pi p upon s square. Now you can solve this. 1 upon 1 minus e to the power minus 2 pi s. If you have common s, this means now pi s. Now remaining e to the power minus pi s, sorry, minus is also, now minus pi s, this means, sorry, plus pi e to the power, sorry, pi is also common, minus 2 pi s. Now again, if you have common, plus 1 by s square. Now remaining is plus 1 minus e to the power minus pi s. Now remaining again plus e to the power minus 2 pi s. If minus e to the power is equal to 2. Now you can put 2. This is your final answer. You have solved to the periodic function by this method, by step. Now you note down the function. First I let x axis and y axis. X and y axis. X is a t and this is a function of t. This is a point of 0 and this is a positive value of pi, and now this is a negative value of pi. I have let this is a first 0 to pi, limit थी हमारे पास 0 to pi and pi to 2 pi, pi to 2 pi. Now my graph is in x and y axis is pi minus pi comma pi. Now I have put this, and now I have down in an x axis. Now my graph is also decrease pi minus pi. Now this is this point value of is x is equal to 2 pi and y is equal to minus pi. This is a graph of ft is equal to t, 0 is less than t is less than pi, and pi minus t when pi is less than t is less than 2 pi. This is your graph. फॉर्मेशन की एक इंटीग्रल है हमारे पास, इवैल्यूएट इंटीग्रल 0 to infinite e to the power minus 3t into t square into sine square t into dt. This is a very important numerical. Now solution of this numerical. First we have cos 2t is equal to 1 minus 2 sin square t. You can find sin square t is equal to 1 by 2 1 minus cos 2t. Now first, now if find out the Laplace of sin square t. Now Laplace of sin square t is equal to 1 by 2 L 1 minus cos 2t. The Laplace of 1 is equal to 1 by s minus Laplace of cos 2t is equal to s upon s square plus 2 का square means 4. Now you again find out the value of t square. This means Laplace of t square sine square t. Now you can write this 1 minus 1 to the power 2 upon 2 d to the power 2 upon t to the power 2 and 1 upon s minus s square upon s square plus 4. Now you can solve this differential. This is s square. Now you solve this minus plus 1 by 2 d upon ds. First d upon ds differential 1 by s minus s upon s square plus 4. You solve this differential 1 by 2 d upon ds. Differential of s is equal to minus 1 upon s square minus differential of this is equal to s square plus 4 into 1 minus s into 2s plus 0 upon s square plus 4 to the power 2. Now you solve this differential 1 by 2 d by ds minus 1 by s square plus minus solve this s square plus 4 minus 2s square upon s square plus 4 to the power 2. Now you solve again 1 by 2 d upon ds minus 1 upon s square minus s square plus 4 upon s square plus 4 to the power 2. Now again differential of this function 1 by 2 differential of this minus plus 2 upon s cube minus differential of this s square plus 4 to the power 2 into differential of this minus 2s minus s square plus 4 into differential of this minus s square plus 4 now differential of this 2s total upon s square plus 4 to the power 4. Now you solve this 1 by 2 2 upon s cube minus plus 2s is common. Now remaining is s square plus 4 to the power 2 plus minus s square plus 4 total upon s square plus 4 to the power 2. Now you can write this Laplace of t square sine square t. It is also write integration 0 to infinite e to the power minus st into t square into sin square t into dt is equal to 1 by 2 bracket 2 upon s cube plus 2s bracket s square plus 4 to the power 2 plus minus s square plus 4 total upon s square plus 4 to the power 4. Now putting s is equal to 3 in this equation. So you can write so that integration 0 to infinite e to the power minus 3t e to the power minus 3 into t square into sin square t into dt is equal to 1 by 2 upon 3 to the power 3 minus 2 into 3 into 3 3 is 9 plus 4 to the power 2 plus minus 9 plus 4 total upon 9 plus 4 to the power 4. Now you solve this 1 by 2 upon 3 3 is 9 3 is 27 minus 2 3 is 6 into 9 plus 4 is 13 into minus 9 sorry this is a minus 9 plus this is a plus is equal to into minus 5 total upon 13 to the power 4. Now you solve this 1 by 2 upon 27 plus 6 into this is cancelled minus 5 total upon 3 to the power 13 to the power 2. This is your final answer. You note down this numerical. This is important. And please like and subscribe to my channel for mathematics. And now I am again discuss inverse Laplace transformation and inverse method of Laplace transformation. You can write this. Thank you.